what should be happening is we are now having various options to solve certain things. And you need to sort of have a think and choose which is the best option for you to solve. So with this one, find the constant k, and I probably led some people down the garden path maybe with this one, because I didn't read the next bit. So if the question said, find the constant k, all right, I would straight away find the constant k. I would just go p of minus 2, because it's a factor, I'd say p of minus 2 equals 0, and I'm off. Danby, Karen, I would change my tactic because I have now read and hence factorize. You guys are now lucky that you can have a calculator, because you could have used your graphics calculator to solve that. But if I said no graphics calculator, what would you do to solve it? Find k and hence factorize. Would your technique change at all? Mine would, right? So if it's that whole thing and I wasn't able to use my graphics calculator, I would now employ synthetic division, right? And it would go minus 2, I would say 2, 1, k minus 4. Oh, that's not very neat, is it? Why? Because I go 0, blah, blah. If it's a factor, I know that this thing here has to equal 0. And you go, yeah, well, I would have got that anyway by doing the blue. But what happens with synthetic division is I now will have here a quadratic. And I can then solve that by factorizing. We looked at that when we had the question with the m's and the z take 2 squared is a factor. So we used synthetic division twice, right? If you did this top one and then you went to your calculator and solved using the, that's okay, because it didn't say that you couldn't. But just be aware there are different values and you have to now start reading the situation. Some people have asked about question 4. And they did, the A was fine, it was part B. And I'd say you do it exactly the same way. The only trick there is that what is your 0? So when we say Z take 3 is a factor, we are very happy to automatically go, well, Z equals 3 then is the 0. So you would then say P of 3 equals 0. Agreed? If we had 3Z plus 1 is a factor, we wouldn't say, oh, Z is minus 1. We say 3Z plus 1 has to equal 0, and therefore Z equals minus 1 on 3. And we can then say P of minus 1 on 3 equals 0. Agreed? So when we're looking at this, don't be lazy and just go, oh, I'll reverse the first sign and not the other. If X take 1 take A is a factor, well, that means you've got P of 1 plus A is a 0. Or back to up here, right? What else could we have done to solve A? Yeah, once you found K, because something, how else could you do? So we've got one method here, blue. We've got another method, pink. There's a third method to solve. Yep, so we'd know that has to be 2x squared. I'm not above saying solve this equation or solve this problem in 3 different ways, using 3 different algebraic techniques. All right, and what would this have to be? -2, and then we've got bx, and then you would equate coefficients. So we've got 3 different ways to solve one question. Maybe I will do. Anyway, any questions with that? We okay? Right, the next one that people have asked me about is 2G. So if you're not up to 2G, you might want to just pay attention for a moment. because it's not a massive explanation. It is just a reminder of things that you have done in the past. And you might be going, she's doing 4, I haven't even done 1. Oh, I'll do the whole explanation. So one of the things that we've looked at already was that if we are told 3 plus I is a 0, what are we allowed to assume? 3 minus I is then also a 0. And as soon as we see that, we can't help but sum and product. Yeah, that's right. So the sum will be 6. The product will be 10. Okay, and therefore what we end up with is we've got now a factor of z squared. What happens to the middle term? Reverse the sign. So the sum, you reverse the sign, so it's now, oops, minus, oh, what have I done? Minus 6z, and keep the sign for the product. Yes? Sorry, I'm sitting in the way for you. I need another chair. I thought I'd fall off. I'm over here. Oops, sorry. All good? Liam, have you done this one? Liam. Oh, I did it. I said Liam. Hello, Liam. I'm mentioning you in another video. It wasn't because I accidentally called your brother Liam. Time of day. Tom. Have you done this one, Tom? Yep. Right, so we've got that. And we want to find a and b and the other roots of the equation. So do I need to go any further? What would we then do, Tom? That's why I've got the bracket there. So, yeah. Z squared, right? Why? Because z squared times z squared gives you the z to the 4 there. If that was a 2z to the 4, then I would have to put a 2 in front of that, yeah? You would also then be able to tell me what that is, equate coefficients to find the middle. You've then got a quadratic, solve it. Agreed? Onward. This was the one somebody asked me about. And when you get to it, you might ask as well. So 1, 0 of this polynomial is purely imaginary. Purely imaginary. What does that mean? Right, there's no constant in front of it. It's purely imaginary, which means it's, yeah, plus or minus I. Now, do we know it's plus or minus I? Or could it be 2i or 3i or 4i? So it's plus or minus bi. Very good. I was going to say ai, but yes, you're better off saying bi. Correct. So, why b? Because most numbers are written as a plus or minus bi. That's how we write a complex number. So technically, lovely Sky, that it's plus or minus bi. Okay, so you still do your summy and your product d, and that would obviously give you, the sum would be 0 because it disappears, and your product would be b squared, and then you go, oh my God, of course I knew that would be, because when we started in year 11 doing imaginary numbers, that's why they came up, so we could factorize things like that. And away you go, you would still do the equating bits. Does that make sense? So it keeps coming up. Okay. Sorry. Yeah, would it be another linear? Yep, because you've got a squared, and we looked here. I didn't even look at the polynomial. Absolutely, it would just be linear. So z, did I say quad? Did I? Sorry. And then you know that that's going to be, and you can then equate, and away you go. Does that make sense? All right. Because I'm not going to see you until Monday, and some of us did not do, and when I say some, I'd say majority of the class, did not do the homework. You're going to have to try and just finish those off, and we are going to start the next topic. So find a little page, new page. So we just want to look very quickly, quickly at composite functions, and also, oh, we've got half an hour, heaps of time, and also look at inverse functions. And it's sort of, again, one will give you practice of the other. And I'm going to say to you, you can do as much or as little as you want of these. All right. Does anyone remember composition of functions? Jack is nodding. Do you remember? Tell us. Oh, he's got it in front of you. So last year, actually, we'll just pop it up. So it's these funny little things here. Okay, so f of g, we've got our functions defined up here. That's another way of defining, I would say, with brackets, f of bracket x, and that gives, but they're just trying to be fancy pants, but we recognize and we're not worried by it. Okay, and this is f of g of x, right? And all that is saying is wherever x is in your f function, replace it with your x value. Do you remember that? So we're going to get into the habit of seeing how that goes. I will be talking about when is a function defined. So sometimes you can actually get an answer for this, but it's not technically defined because its domain doesn't exist. So it has to be for, and I'll write this down later. Today, I just want us to make sure that we can do our simple substitution. With f of g of x, if the domain of g of x isn't in f, then it's not going to work. And I've got an example to show you, but not today. All right, so shall we do one question together? Let's do it. You've got those examples there. I'll leave them for you. It is page, you shouldn't be asking page because it's exercise 3A. Use your little thingies, but 57. So again, if this is my book, when I'm writing this down, I will be writing so I can see what I've done. So exercise 3A, question 1. I don't write how they've written it. I write f of x equals 2x. And I write g of x equals 1 plus x squared. Oh, it's minus 2x. Thanks. Read the question right. Thanks, Jack. Okay, and then for A, f of g of x. We haven't done this for a little while, so if you, I'm a fan of writing in more steps than necessary. And then what is g of x? So we look up there because we've written it down nicely. The other reason that I like to write this, especially when I'm looking at the book, looking up, looking down, you're not messing it up and looking at part 2 when you should be doing part 1, etc., etc. It's just right on your page. Okay, so what, oh my God, I did that wrong. Yeah, okay, I hear the rumblings, I saw the rumblings, because this is what happens when you talk and write at the same time. You make mistakes. G of x is 1 plus x squared. Apologies. So what are we saying? We're saying wherever f is, look at your f function, and wherever the x is, you have to replace it with 1 plus x squared. It's that easy, even though I just got that wrong. Oh, would I expand? I've just come off factorising with my year 10, so I'd probably just leave it like that. But if I have 2 terms, then I would, yes, I would expand and then simplify and gather my like terms. Simples? If you want to, you could do B, but are you expecting to get the same answer? No. So the big thing that they're trying to make a point over here from A and B is that f of g of x will not necessarily equal, I mean it might be for some random, which we're going to look at soon, right? It does not equal. They are 2 different things, clearly. We're all happy with what happens when we've got a number in there? All good, all good, all good? Okay, so they're just going to ask you to go through, practice some of that stuff. You get some slightly bigger functions. Do you remember domain and range? So what is domain? Definition of domain, please. Right, it's basically your x values, okay? Now there are some specific functions that you have to be careful of where we just know things where the domain won't exist. Who can remember some of them? Yeah. So when do we have, yep, they're saying completely vertical. When do we have a vertical asymptote? When does that exist? Okay, so what you're talking about is when we have fractions, right? Let's say blah, 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 blah. Your denominator, when your denominator equals 0, that's when we go, ah, right? That's when we're going to get vertical asymptotes. So you cannot have your denominator equal 0. So we're going to have undefined if denom equals 0. Are we happy with that? When else are we going to have an undefined situation or on your calculator, error? No, exponential just does its thing. There's no, but there's going to be one that's linked to that. Don't make me write it. Right. Square root. We cannot square root a negative number. So if we've got x there, then x has to be, now what I'm saying, undefined if, well, I better write that, so undefined if x is, or when x is less than 0. Agreed? Can we think of some others when we've got undefined functions or when you get error on your calculator? Tom gave us a clue with exponential functions. What's the opposite of exponential? Logs. That's right. So if we have a log function, right, undefined, if we've got ln of x, same deal, or is it the same? X has to be, it can't be negative, but it also can't be 0. So ln of x, it's disturbing me a little bit, but I am definitely writing it's undefined when. Okay, because normally it's defined when it's greater than 0. So I'm doing it, messing with my head. Anything else? Hint? Hint. Trig. So the tangent with the vertical asymptote exists because tan is sine over cos, and the vertical thingies exist when cos is equal to 0. So that's really covered by my fraction. There's something else with trig when we will have error. No. Another hint. Yes, inverses. So your sine and cosine have to go between 1 and -1. If you try and do inverse sine of 1.2 or 2.3, you're going to get error. You've done something wrong, right? So, but that's not, I don't think that's going to come up in your exercise, but it's always handy to know when functions are defined. Agreed? Of course, domain is your x values, so that means range is your y values. So range is all the values that the y can take. Just simple things to know. Probably the one that gets students the most is when you have a quadratic. All right, so if you have a quadratic like this, your domain could be anything. Would you agree? And how do we write that? We say domain x can be anything, any real number. Some people don't write the d. They could just write x to x. How do you get your range? So if I said this was 2, 5, what would your range be? Yeah, y is greater than or equal to 5. So for some of those questions, when they're asking you to do domain and range, consider, is there a square root involved? You might have to use your graphics calculator to draw the function, because that will help you find the range. Like, do you know what the square root of x looks like? So these are functions that you might want to start getting familiar with. So square root of x looks a bit like that. Because if you think about it, the square root of 0 is 0. The square root of 1 is 1. So that point there is 1, 1. My thing is frozen again. I don't know if it's still recording and it's blank, but it just won't let me write on the page at the moment. I hope it pauses the recording, otherwise it's just blank, blank, blank. Anyway, and if you think about out here, like the square root of 100, very small, 10. So it's still increasing, but small, small, small. Doesn't exist on the left-hand side. Why? Because you can't square root. That's right, it's imaginary. So can we work our way through? Oh, I've frozen. Is it still ticking over? I can't even see. Very small. Oh, how sad. Oh, let's hope they can hear us. So can you go to 2, oh, I'm back. Can we go to 2a and truck it? 2a? What did I say? 3a? 3a. That's not very much, is it? And the inverse, you can have a go at that too. Read and note the green. Hey. Inverse reflected in your y, x equals y axis, y equals x, and that's how we find the inverse. Yeah. So finish your polynomial stuff. Do 3a, and I want you to read and start 3b. Question 1, 2, 3.